கொடுத்திருக்காங்க நமக்கு data's 4 parts எப்படி கொடுத்திருக்காங்கன்னா first of revolution is called 750 newton meter to 3000 newton meter. That's the first of revolution. Look it out here, 750 to 3000 for first of revolution, and then remains constant for following revolution. Following revolution means next one revolution. Okay, it will be constant for 3000 newton meter. Then it falls uniformly to 750, from 3000 to 750 for the next of revolution, and remains constant for another one revolution. Okay, 4 parts it will be given. Okay, based on the 4 parts it will be given that. Okay, you want to find out the power as well as the coefficient of fluctuation of speed. Okay, mass of the reciprocating parts will be given as 500 kg, and the radiation of gyration will be given as 600 mm. So these are the given data as well as that graphical representation. I already told about this graphical representation in the last class itself. Once again I repeat, the graph is not given in your problems. Okay, you must draw your graph based on the given data only. Okay, this data will be varies for problem to follow. Based on it will be varies there. Okay, so I already told that 4 parts. So one off revolution, one revolution, off revolution, and another one revolution. Totally 4 parts. Okay, this first of revolution it be rises from 750 to 3000. This one A to B. Look it out here. A to B, 750 to 3000 is off revolution, and then it will be continuous for one revolution. Continuous for one revolution for 3000 newton meter, and then off revolution it will be falls from 3000 to 750. Okay, that's a third one, and then fourth one is called one revolution. It be continuous for some while. Okay, for one revolution. Okay, that's the thing, it will be given. Off revolution means pi, one revolution means 2 pi, and again an off revolution, that's an pi, and again the one revolution, that is a 2 pi. Totally this graphical data. Okay, next we move on to an calculation part. So you want to find out that total area of a complete cycle. Okay, total area of a complete cycle. So here figure of all these things. O, look it out here, O, A, B, C, D, E, and F. Up to this is a graphical area. Okay, that's the thing, you want to find out that total value. Total value of that torque. Okay, that's it, because it will be given as a turning moment. We call it as a torque there, turning moment, as well as it will be drawn again crank angle there. Okay, so you want to calculate the total area of this graphical representation. Okay, this diagram. So I have separated into 4 parts here. So O, A, E, F, it's one rectangle. O, A, E, and F is one rectangle, and then B, C, G, H is another rectangle. Okay, A, B, G is one triangle, and C, H, D is another triangle. So 2 triangles and 2 rectangles totally. Okay, so area of a figure OAEF. First one OAEF, that's the thing. Okay, and second one is called an area of ABG, ABG triangle. Okay, and then BCGH rectangle, CHD. Okay, another triangle. Okay, the data will be calculated based on that. Okay, that is OF into OA, OF, O to F into O into A, length into breadth. Okay, L into B rectangle, and then area of ABG equal to off into BH, off into B equal to AG, AG is called this breadth, and BG is called this height, B to G, this height, B to G, this height. Okay, plus GH into CH, GH into CH, GH into CH, side by side. Okay, S into S, A into A. Okay, GH into CH. Okay, plus off into HD into CH, HD breadth, and CH is called your right. Okay, this is the calculation. Based on this calculation, you get the data of 11,250 pi Newton meter. 11,250 pi Newton meter. Everybody make a note of it, all those things. Just seeing the slides, it's not enough. Okay, you make a note of each and every point. then only you can, while you're revising or you go for preparing for an exams, whatever may be this, just write down, then only you remember what the thing it will be happening in this problem. Okay, without seeing, just seeing that all these things is not enough. Okay, write down and make a note of it, each and every point here. Okay, then only I given almost enough time to take down the notes also here. Okay. Okay, and then 11,250 pi Newton meter. Okay, and total value, total torque value. So if T mean is an torque mean in Newton meter, then torque required for one complete cycle. You want to find out that torque required for one complete cycle. That is nothing but of T mean into 6 pi. T mean of 6 pi. Okay. So equating 1 and 2, equating this equation 11,250 pi Newton meter and T mean into 6 pi Newton meter. Okay, and therefore T mean equal to 11,250 divided by 6 pi equal to 1875 Newton meter. 1875 Newton meter. And next one is called power required to drive the machine. P equal to T into omega. Torque into omega. That is called T mean into omega. Okay, 1875 into omega value is already found out based on the RPM given value. So 26.2, we get the value of 49,125 watts is nothing but of 49.125 kilowatts. Next, we are going to calculate about that. Up to this, the first part is over. First part is called power required to drive the machine. Okay. For finding out the power only, we put all the calculations here. Okay. Up to this, the first part is over. Second part is called the coefficient of fluctuation of speed in terms of percentage. Okay. This is the data. Coefficient of fluctuation of speed. Okay. Again, we go for the triangle, that graphical representation value. Okay. The same graph it will be represented here. Okay, for your reference only, it will put it here. Sorry, students. Wait a moment. Wait a moment. The slide will be skipped. Okay. Back to the class. Okay, this is called, first of all, let us find the value of LM and NP. Okay, LM and NP for similar triangles ABG and BLM. Okay, you want to find out the values of LM, and because we want to find out that Delhi value here. Look at the diagram here. Delhi above the T mean value is called your Delhi value. Okay, above the T mean value. So this line is called T mean value. Above this line only, T mean value. Okay, you want to find out that T mean value here. So for that only we are going to having some calculations here. Okay, Delhi. What is the area should be shaded? That is the area is called Delhi value. Okay, you want to find out that one. So for that you want to calculate all these things. Okay, just first of all you are going to find out similar triangles calculation. Okay, for similar triangles calculation ABG and BLM. ABG and BLM. Okay, A, B, G and B, L, M, because it's a similar triangle. It will be constantly increasing. That's all. Okay, that's the data will be given in the problem itself. Okay, so I've taken as a similar triangles, that is LM by AG, LM by AG, LM by AG, that is equal to BM by BG, BM by BG. Similar triangles calculation, BM by BG. Okay, put it all the values here. LM, you know that, oh, you doesn't know about the LM value. You doesn't know about the LM value here. Okay, and then AG value, you know that, that is 0 to pi, A to G. A to G, you know that, that is a pi value. And the BM value is called B to M. B to M, this value. That is 3000 minus of 1875. 3000 minus of 1875, this value. And again BG value you called 3000 minus of 750, this line. Okay, put together all those things, we get the value of LM equal to 0.5 of pi. LM equal to 0.5 times of pi. Okay, now from similar triangles value CHD and CNP. Okay, this triangle. Okay, you finish off this triangle and this triangle, and this rectangle. Okay, that is your Delhi value only. Okay, புரியுதா என்ன சொல்றேன்ட்டு? Okay. Same as like that, what you've done in the LM and EG, the same thing it will be repeated here for an NP and HT. Okay, so the NP value is again the 0.5 pi value. Okay, and then this value we find that BM equal to CN, BM equal to CN, that is 3000 minus 1875, that is 1125 Newton meter. Since the area of a mean arc line represents the maximum fluctuation of energy, therefore maximum fluctuation of energy equal to Delhi equal to area of LBCP. LBCP, this one. Area of LB and CP, this one. LB into CP. Okay, upper value. Okay, so yeah, I split it again this shaded area into three parts here. That is LBM, one triangle, and BM and CN is in another rectangle. CNP is called another triangle. Okay, that's the thing. Calculation will be done here. Okay, because it's in a triangle of into BH plus rectangle MN into BM plus area of PNC is in another triangle of into B into H. Okay, that's a value to be get here. Half into BH, that is half into 0.5 pi into 1125 plus 2 pi into 1125 plus half into 0.5 pi into 1125. Put together, the value is 8837 Newton meter. And the Delhi value, once you get the Delhi value, remaining things will be same. Already we've seen the same thing, it will be in the first, second, and third problems. Okay, so Delhi is nothing but of m into k square omega square cs. Okay, m value is 500, k equal to given as 600 mm, that is 0.6 meter. Omega square will be given as speed will be given based on this. Omega value is 26.2 square, and then the final one is called as cs value. Cs value 8837 divided by this value, that is 0.071 newton. 0.071. Okay, converted into percentage, that is 7.1 percentage. 0.071 will be answer. Are you clear about this problem? Just go through all of them, go through the problem. Any doubts in this? Any doubts in this? You can rectify it now itself. From first slide onwards, I'm showing the problem. The attendance again the same thing, around 70 only. Around 6 to 7 students are regular absent for regular classes daily. Second slide for the same problem. The third slide. Shall I move on the third slide? Hello. Fourth slide.
சார் இதுக்கு முன்னாடி ஸ்லைடு ஒரு நிமிஷம் காமிங்க சார்.
Okay. Okay.
Oh, okay, sir. Thank you, sir.
சார் அந்த டயக்ராம் ஸ்லைடு மட்டும் ஒரே வாட்டி சார்.
Okay. Yeah, move on to the next slide. Okay. Any doubt in this problem for you, students?
No, sir.
Are you clear about this? No.
No doubts, sir.
Okay, good. Okay. It's a very important problem, man. So many times repeatedly asking this question in an university also. Okay, and in a unit test also. Okay. I already shared a book for you. Okay, please go through in the book also. Okay, the same problem it will be there. Okay, the same thing it will be given in your slideshow also. Okay, okay. I move on to the next problem. Okay, this one. A single cylinder, single acting, four stroke gas engine develops 20 kilowatt at 300 rpm. The work done by the gases during the expansion stroke is three times the work done on the gases during the compression stroke. The work done during the suction and exhaust strokes is being negligible. Okay. If the total fluctuation of speed is not to exceed plus or minus 2% of the mean speed, and the turning moment diagram and compression is assumed to be triangular in shape, find the moment of inertia of the flywheel. Moment of inertia of the flywheel கேட்டிருக்காங்க. Okay. Further, the given data will be done. Power developed will be given as 20 kilowatts and speed equal to 300. What is the value of fluctuation of speed? Anyone can tell that? What is the value of fluctuation of speed? You can see the slide and tell also. Okay, it will be in front of you only.
Okay.
Yeah, Superman, super. That is 4% because the plus value is given and minus value is also given. 2 in a positive side and 2 in a negative side. So totally 4%. Super. Is a given data. Okay. Yeah. Look it out here. That 4% expansion explanation will be given here. Since the total fluctuation of speed omega 1 minus omega 2 is not to exit plus and minus of 2% of the mean speed. Therefore, omega 1 minus omega 2 equal to 4%. Okay. Yeah, the same thing it will be given here. CS equal to omega 1 minus omega 2 divided by omega equal to 4%. What is the value it will be given based on like this? That will be rearranged like this. Omega 1 minus omega 2 by omega equal to 4%. Simply you can write CS equal to 4%. That is enough. No need to this explanation also. Okay. This is a given for your reference only. Okay. For your understanding purpose. Okay. Not for an written purpose. Just you write that CS equal to 4%. That is 0.04. That is enough there. Okay. This diagram is also not given in your problem. Okay, you must draw the problems. Okay, what they told, what is the cycle, you know that. Okay, suction, compression, expansion and exhaust. Okay, and all these things in terms of triangle, it's also mentioned clearly in your data. Okay, suction and exhaust is negligence, so no need to draw this suction as well as the exhaust stroke here. Okay, just mentioning that there's no diagram, it will be represented here. Okay, only compression will be expressed as well as the expansion is expressed here. Okay, there is no need of suction as well as the exhaust stroke here. Okay, the turning moment as well as the crank angle. The same thing, it will be repeated for all the problems. Okay, zero line and then T mean line and then T max line. In between a T mean and T max, the value is called del E. Okay, this is the same thing what we seen in the last class also, last problem also. Okay, above the T mean value up to the T max value, that is the value is called del E. Okay, that's is nothing but of T excess or change in del. Okay, change in energy value. Okay, whatever may be the thing, the same thing it will be there. Okay. Next one is called 0 to pi and pi to 2 pi, 2 pi to 3 pi, 3 pi to 4 pi. Each one it will be taken as in a single pi. Okay. You want to find out this triangle values and then you go for a calculation. Okay. That slide it's not copied correctly, so I written all these things here in a single slide. Okay. Work done per cycle will be given as total area of the turning moment diagram. Okay, work done per cycle equal to total area of the turning moment diagram. That is W equal to P by omega. Work done equal to is nothing but of T mean into theta. So T mean into omega. Okay, the T mean P by omega. Okay. We get the value of 20 kilowatts already given. So 20 into 10 power 3 divided by omega value is called 31.42. That is 637 Newton meter. And then next one is called work done per cycle, WDPC. That is work done per cycle, T mean into theta again. That is 637 into 4 pi. That is 8000 joules. That's the same thing it will be given here. Okay, T mean into theta here. That's T mean into theta. That is work done per cycle. Okay, you're going to calculate. This T mean P by omega is different one. Okay, P equal to T mean into omega. That's a formula. Okay, and rearranging that, T mean equal to P by omega. That is 637 Newton meter. The work done per cycle equal to T mean into theta. That is 637 into 4 pi. That is 8000 joules. Since work done during expansion stroke in 3 times of the compression, it will be given. Okay, expansion stroke it will be 3 times of the compression. Okay, W equal to 3 times of WC. That's the thing it will be put it here. Already we know that work done per cycle is 8000. So 3 times of WC minus of WC because expansion stroke is a 3 times. Okay, so W of 3 WC into 3 minus of WC equal to 8000. Rearranging of all these things, we get the WC value, that is 4000 joules. And then WE also we can get it. WE is nothing but of 3 times of this 4000, that is 12,000 Newton meter or joules. Okay, the area of a triangle ABC you want to calculate. I've given the diagram ABC. Okay, A, B, and C. This one. Okay, half into BC into AG. Okay, similar with a triangle area. Okay, half into B equal breadth equal to pi. That is a BC, and AG equal to height. Okay, so in terms of AG, you want to find out AG equal to 12,000. Total value you already got it. Okay, 12,000 Newton. Okay, 12,000 Newton meter. So based on this, you can find out the AG value. AG equal to 7638 Newton meter. That's a T max value. Okay, just you got the values here. Okay, just you mentioned the T max, T mean. That's all here. Okay, you didn't know the value there. Okay, now you got the value of T max equal to 7638. Okay, and the excess torque T max minus of T mean. Okay, AF equal to 7638 minus of 637. So 637 already we find out here, and 7638 we find out here. So 7638 minus 7638 minus of 637, that is equal to 7000 Newton, 7001 Newton meter. That's the thing, it will be given in the diagram itself. Okay, excess torque, that is T excess equal to T max minus T mean. I already mentioned that T max minus of T mean is called excess torque. Excess torque is nothing but of Delhi value. Okay, that is 7638. You already find out the AG value here. Okay, A to G, this length. Okay, and then this value is FG equal to 637. Okay, FG here 637 here. Okay, that's the thing is called 7000 Newton meter. Now Delhi equal to area of a triangle DAE. Now you want to find out the Delhi value. Delhi is called this shaded area. Okay, for similar triangle calculation. Okay, put it here DE by BC, that is AF by AG. Okay, cross multiply of all this. So you want to find out the DE value now. This breadth. Okay, DE equal to AF by AG into BC. So AF value you already find out that is 7000. AG value is 7638 into BC value pi, and so DE value equal to 2.88. So area of a triangle equal to half into B into H. So half into B into H equal to, you got the value of 10,800 Newton meter. So that Delhi equal to M square K square omega square CS. Okay, M into K square is nothing. Okay, எந்த லைன் வரைக்கும் தெரியுது?
ஏரியா ஆஃப் ட்ரையாங்கிள் இப்ப சொன்னீங்களா சார், அது வரைக்கும் தான் சார் தெரியுது.
இப்போ தெரியுதா?
இப்போ தெரியுது.
கொஞ்சம் சின்னதா இருக்கு, பார்த்துக்கோங்க, ஜூம் பண்ணி பார்த்துக்கோங்க. M into K square omega square CS. M into K square is nothing but of I. So I into omega square CS, cross multiply of all these things, you get the value of I, that is 255.2 kg meter square. இந்த சம் வந்து பார்க்கறதுக்கு கொஞ்சம் பெருசா இருக்கும், but it will be very very easy sum. Once you go through all these things, it will be very easy for you. It will be very easy for you. ஒரு வாட்டி கோ த்ரூ பண்ணுங்க, இந்த டயக்ராம் பக்கத்துலேயே இருக்கு உங்களுக்கு, ஒரு வாட்டி கோ த்ரூ பண்ணுங்க. நான் ஃபுல் ஸ்க்ரீன் வைக்கிறேன், and then ஷார்ட் டவுன் பண்ணுறேன். If you have any doubts, you can clarify now for this problem.
Sir, for இந்த கொஸ்டினுக்கு டயக்ராம் நம்ம வரையணுமா சார், இல்ல அவங்களே கொடுத்துருப்பாங்களா சார்?
A good question. In the I'm giving the question once again. Okay, so look it out here. This question, this is a question. In this question itself, they clearly mention all the data. Okay, you want to draw the graph. Okay, the work done, look it out from the second line. Work done by the gases during the expansion stroke is 3 times of the work done on the gases during compression stroke. Okay, இது ஒரு line. Okay, and work done during the suction and exhaust stroke is negligible. Suction stroke exhaust stroke negligible சொல்லிட்டாங்க. And then total fluctuation of speed is not okay, this thing remain okay. Plus or minus 2%, அது நம்ம எடுத்துக்கலாம் 4%, no problem. And the turning moment diagram during compression and expansion is assumed to be triangle in shape. கொடுத்திருக்கா லாஸ்ட் லைன் பாருங்க, the turning moment diagram during compression and expansion is assumed to be triangular in shape. கொடுத்திருக்கா இது ஒரு பாயிண்ட். And then suction and exhaust stroke negligible பண்ண சொல்லிருக்கு. ஓகே, இந்த பாயிண்ட்ஸை வச்சு நம்மளே தான் டயக்ராமை ட்ரா பண்ணோம். இந்த டயக்ராமை நம்ம தான் ட்ரா பண்ணோம். கொடுத்த டேட்டா என்னன்னு பார்த்தோன்னா சக்ஷன் அண்ட் எக்ஸாஸ்ட் இஸ் நெக்லிஜென்ஸ். ஸோ நம்ம ட்ரா பண்ணவே இல்லை. அண்ட் ரிமைனிங் கம்ப்ரெஷன் ஆஸ் வெல் அஸ் எக்ஸ்பென்ஷன் ஸ்ட்ரோக் எல்லாமே இன் டர்ம்ஸ் ஆஃப் ட்ரையாங்கல்ல இருக்குன்னு சொல்லியிருக்காங்க. ஓகே, புரியுதா? ஸோ இதுவும் ஒரு ஸ்ட்ரோக், இது ஒரு பை, இது ஒரு பை வேல்யூ. இது நம்மளுக்கு ஏற்கனவே தெரியாது. ஓகே, ஒரு சைக்கிள் முடிக்கிறதுக்கு இட்ஸ் கால் கம்ப்ரெஷன், அந்த another சைக்கிள் ஸ்டார்ட் ஆகுது இட்ஸ் கால் எக்ஸ்பென்ஷன். ஓகே, அந்த சைக்கிள் மூலமா தான் வந்து புரியுதா இப்போ?
எஸ் சார்.
So diagram already பாருங்க, and then I move on to the next slide. I move on to the next slide now. And A, B, C, D, E, F, G இதெல்லாம் இந்த நோட்டேஷன்ஸ்லாம் வந்து that's our wish only. Okay. Still 5 of them is missing in the online class. Are you any doubts in this? Or you go through? There is any doubt or any clarification needed for this problem?
சார் இந்த ஸ்கிரீன் மட்டும் கொஞ்சம் அப்ல வைங்க சார், கடைசி லைன் தெரியல.
வைக்க முடியல.
சார் ஒமேகா வேல்யூ 31.42 அது எப்படி கண்டுபிடிச்சாங்க?
ஸ்பீட் கொடுத்திருக்கல, ஸ்பீட் ஈக்குவல் டு given value based on the speed.
ஓகே சார், 2 pi n by 60 அந்த ஃபார்முலா. 2 pi n by 60.
ஓகே, 2 pi n by 60. Yeah, it's okay now. The slide is will be visible for you.
Yes, sir.
Yes, sir.
Any doubts you can ask it. The session is going to end now. Please go through the sums in your book itself. Book also. These are all the data, all the what you learn about in online classes. All these things will be available in the book also. I shared the book through Google Classroom as well as the WhatsApp also. Okay, go through all these things. Once you go through all these things, only we can attend the uh, MCQ questions. Okay, online quiz questions. Okay, it will be falls on Friday 4 o'clock. Suresh sir, you want to speak anything? You can continue.
No, sir. We will wind up the session now, sir. Almost we are.
Time over. Okay, sir. Thank you, sir.
Thank you.